anybody have any?
Great. Many-to-one relationships. So here it is, working with this raw data. The power is in the raw data. It's also where it gets really hard. Here's the raw data you can see right here. It's the edge ID. You can see there's many different edges in there, right? They're all the same though. This one's 56, 56, 56, and then 65. And they're all for these different, date 174, 172, 178, and this is 12:22 p.m. and this one would be 3:59 p.m. And then the number of cyclists in each direction, the number of trips in each direction, and then your total number of time in each direction as well, and then how many of them are on a commute trip. That's great. How do you use that, right? I mean, it's a many-to-one relationship. You can't just join that back to the street network. It's going to blow it all up. But yet there's a lot of really important information there, right? Also, these records are like millions of, I think 250, 300 million records long, and so you need to be able to put this into something that can digest it and handle it. And file geodatabase can. Obviously, a DBF can't do that. I think the 2014 ride data, when it was unzipped, is about 28 gigs. So, therefore, this is where we use PostGIS. PostGIS, spatial SQL Server works, Oracle Spatial. I mean, all these spatial-enabled databases work. We just use PostGIS because it's free. So to do this, right? Let's just talk it through. We create a table. You need to create the table that you're going to feed the data into. Here, so here's an exact snippet from PostGIS and how you would create that table. So, right, create a table. In this case, we'll use Brevard edges. It's county in Pennsylvania. And you break down your edge ID, your edge by integer, year by integer, so on all the way through, so you have all your data accounted for. Then you start to do the copy in, right? And this is where you actually move all that data over from the CSV file into the table, right? Because at this point, you can't open a 10 gig CSV file. It's not going to work out well for your computer. If you're on Linux, you can do a quick little just grab the top 10 lines of it. But again, that's not everyone is fluent in Linux. So this is a little piece of code again that lets you say, okay, look, if I have my table already built and I know my CSV file structure, I can just port all this into a relational database table. Now I can actually view it, or at least I can start to play with it. And what I do with that table as soon as I put it in there is I add a date time field, right? Because you can look at Julian dates and times and things like that, but who really talks about day 6, like 274, right? I mean, it's not something that we as humans really deal with. So then what we do is you have to then update that, of course, right? You can create that field, but then you have to do a update, populate it with the correct day and populations, and then of course, with all things spatially enabled, you build your indexes. I always find index on hour, edge ID, and date time to be the 3 most important ones. And it really lets you start to zip through the data and create some really cool and exciting roll-ups that gives you insight into the data that you wouldn't otherwise always get the other way. For example, counts by day, right? Select, and this is just SQL, but in progressive complexity. So select day count all, group by the day, right? So that's going to give you a count by day, day 1, 2, 3, 4, 5, 6, 7, all the way through your entire year. So you can start to get this movement, and I'll give a typical like Vermont, where you kind of get like these nobody's really using it, and then May comes, June, winter, right? Something like that, and then you can graph it out. You can also then add in commutes onto this, right? So you can also then say, well, only give me, you can put in something like this little clause over here, this extract where day a week is 1, 2, 3, 4, 5. So now you're only looking at potentially counts for the day of the week, and then you can add in where commute equals 1. So now you're saying, you just give me all my counts and series for Monday through Friday, where there only commutes. Now that's even more powerful, because now you can actually you're subsetting weekdays for commutes for a year trend, and you can start to see. And what do you start to see? Some really cool features like, oh yeah, look, here's Memorial Day, July 4th, where all these holidays just pop right up as days that just drop off on your calendar. Or the second one, day of the week. So if you actually just want to actually see, what are your most popular days on cycling, you can see what a Saturday pulse is and a Sunday pulse. There was a misconception going on for a little bit that there's, the weekend trips on Strava must be 2 to 3 times greater than the total sum of all the weekday trips, because there's such a recreation-heavy, Lycra-only user group. the reality is that actually about 60% of all the trips collected by Strava users are during the weekdays, and then 40% are on the weekends, right? So it's because the Strava users use the product all the time. So then here's another one, hour pulses. So what if you're actually just looking and trying to figure out what's happening on your hour-to-hour pulses for just the day of the week, right? So 0, 1, 2, 3, 4, or 1, 2, 3, 4, 5, grouped by the hour. So you're extracting hour from your time frame, then you're summing your total activity counts, and then you're refining that only to Monday through Friday. So now you can actually see on your 24 hours, 0 through 24 to 0 to 23, what your total number of use per day is on during the week. And then if you want to, you can just replace the 0 and 6 from the 1 through 5, and now you're looking at just your weekend hour pulses. Just like that, you're just able to crank through your data and start to pull out all these just really quick, low-hanging fruit that just requires you to put the data into a relational database. Okay, but now you can switch it all around. You can say, okay, well, give me my year, month, day, hour, and from. Give me my sum of all my athlete counts. So give me all my users. Give me all my activities. Give me all my reverse activities, and then give me my median times and in each direction. So you're like, wow, now I got a lot of data. So I got median activity times in each direction. I've got sums in each direction. I got sums total, and I'm extracting all these different levels of temporal pieces from my data, and I'm calling that G date, right? This is G date down here. And then I'm extracting this where a group, but then I'm taking all this and saying, but I only want it for this set of edges, for this one street. And this is a street downtown. They did I think it was on 3rd Street. They painted a big green lane down the side with people for bikes, and they were really curious to find out what the use change was from one week to the next week from when they did this. So what you do is you take all those edges and you find your date time frame, right? So you're only summing this week, those 10 days, all that information, sums the athletes in each way, time, everything like that, by this, and you run it, and you get a total number summed up for that whole piece of stretch of geometry, right? And then you run it again, and you just change the dates to, let's say, 10/7 through 10/17. A month later, what does it look like? How different is it? Stuff like that. So now you actually start to say, what happened between 2 separate weeks, or 2 separate within a month as a result of us opening up a new piece of cycling infrastructure. And there's more and more and more you can do with this, with the arrays on the OD matrix. You can go through and you can it's called explode arrays. You can explode arrays and create distinct arrays and find out which arrays were connected from more groups and rides and others and things like that. And be happy to help anybody who really wants to go that deep into the data. So all that data above gives you back this, right? Then this is really what I love. So this is why Strava is representative, because Strava's behavior is dramatically different Monday through Friday and the weekend, right? Because the riders use it for different purposes. They're the same rider types, they're the same people, they just happen to use it to get to work, and then on the weekend they jump out and ride. And what we find is our data shows a ramp up of the overall population before the counters show the peak population ramp up. Anybody think about why that might be? It's because we start to show when the person starts a ride, and counters are usually deeper in a network. Right? So it takes a while for the individuals to get to those counters on a weekend, whereas we can start to show the second they walk out the door. And it's also really good to show about seasonality right here. So here's kind of a low ramp up in Seattle. And then it must have got really, really cold, really, really rainy in spring. Shocking. And then here's their bike to work month. And then Memorial Day, it drops into their seasonal lull, and then it drops all back off into their off season. So it's just really fast ways to get that visualization in there. All right, I'm going to jump over to the user guide for a little bit, because it is really awesome right now, and there's no way that I could duplicate all the information here in slides without boring everyone to death. So we built this user documentation. Everyone should have it. It's in the beginning, it kind of talks more about some of the things we've gone over now, or streets, origin, destination, etc. There's a little bit of a how-to in there as well. What I wanted to get down to was the actual fields and talk about what those look like. But there is a plethora of information here. I think it's like 46 pages or something like that. But again, you can start to see in there like what are the table structures that we're providing. There's a little bit of how to join some of the data together for simple, like just ESRI analysis. We'll jump into some of that as well still. But I really want to get to right about here. So we already saw this table, which talks about the different types of rollups that we provide and the naming nomenclature that goes into that, right? The identifier, FL, run, and what year and seasonality and month it is. But then we can start talking about the metro edges. That's an OSM. Here's kind of your here's how the definition of labeled as _0, _1, 2, and 3. Right. So these are the hour rollups, and so the rollup is twofold. The rollup is not only is it for the whole year, but it's also for the given time frame of within that year. So you have like June, right? And then you have _0, which is going to be your midnight to 5 a.m. And then you're going to have your _1, which is going to be your 6 a.m. to 10 a.m. And so on until you get to the end of the day. So you have the ability to see the data rolled up by the big temporal block as well as your small hourly temporal roll-ups for each one as well. So it's like a double roll-up in a way. And then at the end, of course, you get the total sum. And then you can see like here's your naming culture right here. It's ath count, rev ath count, rev ath count, total athlete count, total activity count, activity time, reverse activity time, and commute count. Right? That's the key set of 9 fields that are right there, and then those are repeated with an _0, _1, _2, _3, in reflection to your midnight to 5, your 6 to 10, and so on. Right? And so that works for nodes as well as for the streets layer. And these are all based on the time is in seconds, which is important to realize, and the activity counts are obviously in digitization direction going both ways. And I think, did you put this up on the, yeah.
This is available as a handout, and anybody here in the room has a jump drive and give it to
you. Yeah. And again, it's yeah, Joe?
Yeah, Sarita Taylor in here has been working with registering for all folks that are there. So if you don't mind sending an email to Sarita Taylor, and then she'll follow up and send you the document also. Yes. Yeah. Okay. Thank you.
And just to piggyback on that, I was going to save it for later, but Sarita, I have a couple of questions that I'd love to ask the audience. We're trying to create some really new things, and getting the feedback from this pretty vast group would be pretty incredible. So if I could put a couple questions on that, that would be fabulous.
She said perfect.
Super. And again, so then you go back to the raw data, right? And this is what the raw data looks like, and the athlete counts, and the rev count, and activity counts. And it's the exact same concept of the utilization representing by the rev or the R in front of it. And this goes through your OD data where you get your intersected polygons all the way straight through. Okay, so not to go too much into detail, but this user guide really has a lot of information associated with it. It's a really good reference point to go back to if you're like, I don't understand what this column is about or what is it trying to show me. It's probably a good time to talk about one of the things with uniqueness, right? So when we do roll-ups, we're able to, we being Strava, we're able to create unique views of cyclists and activity trips per that roll-up. If you were to go back in to the raw data and try to create that same exact roll-up, you would have many more numbers because you can't go back because the raw data is unique to the minute, right? Whereas when we roll it up by the hour, we can go back, retouch all the athlete and activity IDs, and create a unique view for just that hour. So just so when you're thinking about it, just remember that if you go back to that and you start doing summaries on the raw data and you try to mimic back to what we provide for the summaries, they're going to always be higher. Now, in relationship to each other, if you roll up the data the same way and you compare it, then you're going to be able to compare those to each other because you're duplicated evenly across both pieces. But just saying, like it's It's a uniqueness down to a minute by the raw data, and then we're able to provide the other roll-ups that can provide uniqueness to it for summaries. If there is a big summary, if there is a big unique view that you'd like to see, let us know. We also have some ideas in the works for how to create something that will allow anybody to create a unique roll-up as well. But that's not tomorrow. Okay, let's jump out of that. So the entire product is a big join. Everything's joined to the IDs. We provide data. That's what we're providing. Right? We're providing data, a whole quiver of data files that we're joined back to either street IDs in this case, right? So you're joining your ID of your streets to a given edge rollup by the edge ID, and you hit OK, and now that just smashes all those edges together with that data, and now you have this really nice representation of data, right? Which is very similar to what this is going to show. So this one right here has the 2014 ride total weekday associated with it, and let's turn off the Orlando only one. And we have athlete count, so it's total athlete count, and it's just a scale of 2. So you can just see for the weekday total athlete count, right? And that's just joined together by, let's see if it's going to open up. Yep. So you got your ID. Of course, you have all this attribution. That's all here attribution. But then as soon as you get through all the here attribution, you'll find the edge ID, here attribution, right? So there's your edge ID, join, and then here comes all of your data associated with it, _0, _1, _3, 4, and then your total sum for that time period. And then so you can obviously do some type of sorts because it's just arc, and that you just kind of bounce back and forth. Oops, that's not the one I wanted to do that on. So you'll notice that's 1.8 million records. It's not going to be happy about that. So we'll come back to that one in a couple weeks. So then let's go working with the edge data. This you guys can see. No, of course not. Okay, so what I wanted to do here was say, let's compare weekday commute time to weekend total travel time. Are the routes and patterns and paths that let you do that, that let you start to compare these. And if I do that, will it? All right, well, cheat. So here was the original piece. Let's move it to the front. All right, so what I did here, it's like I took a subset of the data for Orlando, because obviously if you mess it with 1.8 million edges, that's going to be really cumbersome. So it's a subset of 88,000 edges. Join the IDs to to the weekday and join the edges to the weekend, and then create just a subset of that. So this first set is weekday total app count, total activity count, and your total commute count. And then this one is your weekend, the exact same thing, total app count, total activity count, total commute count, all for the same exact edge. What's exciting here is you say, oh, look at this. This high-level commute count on this one, 965, only had 151 when you look at it for the weekend, right? Great. This is showing me that I'm now dealing with primarily a weekday commute corridor, and it's not really highly used for the weekends. And that, let's move this one forward, is what this starts to show. Should show. Right? So a difference of 814, in fact, right? So these red values right through here are your routes that have a higher commute count than a weekend count. So you immediately start to say, okay, well, here's a blue one. That's definitely a little bit more on the weekend heavy, but for the most part, there's a couple main corridors and arteries that come in and out of the city, and one runs right through the middle. They're not used as much on the weekends. Great. So what about if we reverse that? And again, this is just creating a field. It's a simple field in ARC that just says, okay, well, merge this, export it out, or join, export, and now create me a new field called delta. And that delta file is just a difference between the two time frames. And when you do that, you can start to create some different views into it. And here is the reverse, and this is your weekend heavy routes, with the red being some pretty heavy weekends, and your blue not being so much. So then we would take that to the intersection level data. And so here, what the idea was, what we had was this big bridge in Seattle, right through here. And we knew that this was by far and away the most heavily used piece of infrastructure in the entire city. And it kind of comes to this point and then rips this way and rips right into the heart of the city. So if that's the case, then what on this point is potentially our largest bottlenecks, right? Because you can display all the nodes and start to get a little overwhelmed with like Pac-Man or whatever, and you just kind of get lost in the data. But when you really hone in on a region, you can start to see these points that really start to isolate and pop up as potential waiting blocks. So here's this main corridor in. There's a couple blocks on the highway, not too much, and then it really speeds up here. So if you're going to move back up the network, you would say this would be the next intersection for us to potentially look at, see if there's a way to increase that speed, because we have a potential wait of 3 to 5 seconds there, and so therefore can we continue to reduce these and make them waits of less than 1 second. And then again, overlaid on top of the use corridors really lets you start to figure out which ones work better than the other ones. I know we all know how to use field calculator and things like that. Some things that I found helpful, calculating edge per speed from seconds. We don't provide length speed, right? However, we provide a lot of things that let you do speed, right? You know the edge of the length, you know the time. So therefore, then you can start to figure out how fast is somebody going, the general population going on a piece of edge. Therefore, you can start to create your total through flow on a given network by trying to figure out, like, okay, if these groups, if these roads all can move at this speed across this network, and these intersections have these kind of wait times, what can we do? Take that one step further and kind of do what we do on Strava Metro, on Strava, right? Let's see. We provide you actually with a routing cost. Most routing costs have been typically they're just car algorithms with kind of half-baked for cycling infrastructure, and that doesn't really work right because cyclists will go way out of their way to create or to get to work to avoid a couple things. So what we can show here, and let's see if it'll work. Probably never do live testing, but well, what we can show is we've actually behind our entire map here, we've already baked in a ton of data, and if it lets you kind of just route from point A to B and let you go around, right? So that's the most popular route. If you were going to choose a route to not go through the city, to go from that point to that point, that is where you would want to go. If you were going to take Google, that's what you would do, right? So what we've actually said is the majority of all the cyclists, if you take into account what the cycling population is doing and use that as your cost structure, instead of saying, okay, well, minimize this, maximize this, minimize this, and just use tertiary roads over secondary roads, you're always going to get a short point to point. But cyclists don't do short point to points. They do what's safest, what feels the best. And so that's the data we're providing you guys. You guys have the ability now to create your own cost algorithm to route around and through every city. You have wait times, you have delays. You can create some really amazing model structures with all this data this way. Let's see what happens if we do that too. Right. And if we actually really wanted to go into the middle of the city, what's it going to do? So it's a pretty cool tool. Don't use Google Maps on it because it won't make any sense because it's all built on OpenStreetMap. Let's see.
So is that based out of, so what other cyclists basically, have found to be the easiest way, and hopefully if we have built a shared use trail of some sort, then hopefully the cyclists that's what they're using.
Right. Yep.
And that is based on, is there any cutoff point for popularity?
There's some like algorithm that decays this to a certain point of distance. It's not going to force you all the way out to get on something just because it's got some popularity. There is some level where they're like, listen, you can't go 10 miles out of your way to hit this popular route, right? That's just a little silly. Like all routing algorithms, there's always a little pieces where you go, really? But for the most part, it definitely seems to reflect what the cycling population does more often than not. In particular, and like it hits the wiggle really well in San Francisco and things like that, which most of the routing algorithms won't do. And if you want to, it does also have the global heat map layer, which you can turn on underneath it at the same time. and start to see.
What kind of layer is that?
This is the global heat map layer.
Oh,
That lets you start to explore some other routes as well if you were interested. Okay, and when we build this, we use a subsample, so we actually don't use all the data you guys have. You guys can actually create a better routing algorithm than we can, because if we were to run every single point through it, it would never finish. But since you guys have the ability to create cost algorithms just based upon AM commute data, then you can actually really get a really close AM commute route choice versus a weekend route choice, where ours is more of a collective population of cycling choices, because we're pulling something called density saturation per per linear mile, and you guys have everything. Okay, back to this. Also, filtering points, right? It's really important to constantly be thinking about what you're seeing and what you're viewing, with what your end goal is in mind. If you're only interested in certain dates and parameters, then make sure you're only looking at those type of data with those edges associated with it. If you only care about routes and corridors that have more than 10 total trips on it, well, then filter out so you're only looking at those routes and choices with 10 trips on it. Don't let the volume of big data drown out the interest of what you're trying to solve, right? I mean, just because it's all there doesn't mean that's what you need to be looking at. And I think that's kind of what some groups get a little bit distracted on, is they just kind of say, well, all this data is there, we can only look at all the data, display it all, and it didn't tell me what I wanted. And the reality is, well, focus on, ask the question and make sure that you're refining the data to solve your question before you just start tossing it up and symbolizing things. One thing I like to use all the time is percent change. What the Metro product is really good at is showing change. What happens when you do something one month compared to the next month? Because the Strava user is so engaged and so consistent that they're able to show you what they're doing on their cycling network within that given time period. So you can say, okay, show me June versus July. Okay, we had a big natural disaster. Show me what happened that month after that, the week after that, with all the cycling behavior. We did it in Colorado after all the floods like 2 years ago. We did it after the which hurricane was that up in Vermont? I'm beginning to think. But anyways, big huge hurricane through, and it was not awesome, and it took out the majority of all of our roads. Sandy? No, that was the low one. I don't know. Irene. Yeah. It destroyed Vermont. I mean, like every single pass road was out for the whole summer after that, or I guess it's fall. Okay, so I want to talk about some early pitfalls. How are we doing on time? Super. Small segment oversaturation. This is a big deal because it can really give it can really skew your top 5 or 10 results. And if you do a big symbolization, it can make all the rest of your more key larger routes that you use kind of look more damp than they really are. The longer a piece of road and the better the match, the better your representation is of that. If you do, so example, if our buffers, those big circles that we were talking about before, if those are all, let's say, 50 meters big, and they're collecting these buckets of data, and then but then that piece of edge that you're analyzing is only 25 meters long, well, they all cross each other. The whole thing is covered by every single buffer, and now you're over counting. You're counting one and the other, and now you're potentially counting also some stuff that's on the street, right? And so really small pieces of geometry, I like to even say like 50 meters and smaller, I just don't give it as much weight, right? Because you're going to have a larger piece of geometry there anyways. So just kind of just look at it when you sort it. If you see this value that's just like 10,000 and the next highest one is 5,000, I bet it's probably a 10-foot wide piece of road geometry that's right next to a super corridor that's pulling in everything. And therefore, you're just like, that's an oversaturated segment. Weed it out. It's noise. Low node rollup values. This is a bug that we found. Actually, it's not really a bug because it's statistically doing exactly what it says it's going to do. It's just a reaction of how we create the rollup data as from the raw data. So imagine this: you have an intersection, and you have 5 records that go through that intersection. 4 of those records are people that there's only a single cyclist, and they just rip through there, and it's a red light, right? And so the wait time is like 0 or maybe 1 for them to get through the whole thing. Then the next one is actually it's just one record, and it's 10 cyclists, and they're waiting for 30 seconds. Well, if you do a median on those 5 values, your maximum weight, your median wait time for that is going to be 0, right? Because the median of 5 values is going to take the middle of it, and that's going to be 0. That's not really true, because you weighted those 20 cyclists in that one record the same as you did the 4 others who went right through. So it's doing the right thing, but it's really low right now. The raw data, though, if you go back to that, you can start to do that, what I call that weighted average, where you would multiply that 20 by that 5 seconds, or that by that 30 seconds, and carry that over, and then divide by the total number of cyclists. Now you have a weighted average wait time, which is going to give you a much better average waiting time. It's just something we're just figuring out as we continue to go on some of this data. We're also starting to work on ways to start thinking about, what if we were to only care about, if the wait time maybe should only be people who are waiting, right? I mean, if you're not waiting, just go right through. And we know what that's all about. But what if we're only, if someone's going to wait there, what's their typical wait time? So let's only value people who are waiting. Gravitational pulls, we've already spoken about the gravitational pulls. This is where you're trying to compare a small town to Orlando, and you're viewing them together, and you're like, well, there's nobody rides there. Well, that's because they're completely getting drowned out by Orlando. So remove Orlando from the equation, focus on that, analyze that, now put them back together. Or better yet, put them both on a 0 to 1 scale, right? Normalize them. You take, give me 0 to 1 here and show me my top routes in this section, 0 to 1 top routes in this section. Now you can really start to see what's going on. Because when we do our national routing, really, if we didn't renormalize by zip codes, everybody would always be routed to New York City or San Francisco or Portland, right? Because it would just be like, it's the best place, and it's not the best place. There's a lot of people there. Outlier data points, kind of like those small segment oversaturation. There's just going to be some just really strange stuff. Wait times, so for example, when someone's sitting there and maybe they have coffee on the corner, and it's a 2-hour wait, and there's a second, some gigantic 20,000 seconds wait for an intersection. Toss that out. We decided not to filter through the data and let you guys do that, because again, it's your guys' network. You know your users. You know your streets better than we do. So for us to start to just throw out data for you guys doesn't make sense for us to do it, and you guys can throw the data out yourselves, right? Let's give it to you guys. Valence 1 nodes. So if you have a really hot corridor running back and forth on a street, right, and you have these tiny little dead-end valence 1s coming off of it, and again, they're really short, and this is where you get that little short thing. These are going to catch, right? If you have a buffer here, here, and here, and you have all these points coming down like this way, and you're grabbing those points, this whole piece is going to light up. That's going to light up. That's going to light up. Again, it's just a matter of spatial tolerance and buffering. Missing the poor alignment. I don't think you guys are going to have this problem here. But learning about global base map networks, you've come to expect some pretty wild stuff. In this case, you'll notice that this point over here, there's no break coming off of here to here, right? See, there's no node. There's no node for this piece to match to right here. So then the closest node is here, and probably the next one is up here. So there's no way that you're going to find the number of people coming from here to here, because there's no place for us to hook to, right? We're not making geometry, so you're going to miss that piece of population going from here to here. You'll start to pick it up from this point to this point, but there's going to be this strange gap of kind of like a little loss here, but not much here. The same down here, there's a strong percentage of people coming up here, and they're missing geometry. The same for right here. This base map network is just not complete with all the geometry necessary for us to make a clean match to it. This is in the middle of nowhere, Idaho, and since then they've gone back and they've really cleaned it up, and the matching is much, much better. And with you guys being on a system like NAVTEC, it's going to be a good, clean match. The only time that you might find issues and errors is if NAVTEC and TomTom both, they're just not notoriously known for having a lot of good trail geometry and kind of sub alleyway geometry and stuff like that cyclists might use. So just be aware that if you're looking for something and you don't see it, go back to the base map and see if it even exists in that base map. Because if it doesn't exist in that base map, we can't map it, because we're just not quite there yet to be making base maps.
Maybe that's in case you see a little gap there on the left-hand side that looks like it's missing bottom middle page to your right. Yeah, that goes to right there.
Yep.
No, the white you know, how there's nothing throughout the white lines.
Yeah.
Yeah.
Yeah, they have. This one has a lot of issues.
And I don't think NavTech will look like that. I mean, maybe like you're saying, when you get to trails and sidewalks and things like that. But NavTech is getting better. I mean, they have, for some malls, they have the parking lanes in the mall. So, I mean, they're improving their data set, but it's for vehicles, so you can't expect it to be everywhere. But they are certainly expanding to walking and biking.
Yeah. So that's kind of where I had for hour 2, and we're right on target. Joe, were there any questions there?
Let me check in. Any questions here? All right. Nope. Nothing from this side.
Okay, so what I'd like to...
Well, I know Sean Davis is there with you, and there are a lot of questions. Since we're in the tech session here, I would kind of lean more towards Sean there, who's there with you, to kind of maybe speak up on some of the online tech questions. So it'd be great if you could pick 1 or 2 from those folks that are on the line.
Sure thing. One of the ones is the time. Somebody said they saw time at 0 to 24. Wouldn't 0 and 24 be the same thing?
So yeah, 0 and 24 would be the same. There's really no 24. It's 0 through 23. So it was 0, and it was 0 being more or less midnight, and 23 being 11 to 11:59.
Somebody asked, I guess this would have been from the previous section when we were talking about demographics, but how does Strava differ from Cycle Atlanta or Cycle Tracks as far as demographics? Is it still pulling from the same user base?
What we find, the only direct correlation to the study that's been done so far is with Cycle Tracks Atlanta, and we kind of worked with them. We actually ran all their data through the Metro process. It's another thing that we kind of learned how to do. We've been processing anyone and everyone's GPS data, because actually it's really hard data to work with when you start scaling it up. They just couldn't figure out how to make all the data align to what they were hoping to do. What they found is their use was obviously much lower than our use, and their demographics was much younger because they were pretty much on a college campus. So therefore, most of their advocacy and promotion work and things like that was all on the campus. So I think the majority of their users were 18 to 24. They did have a 2% higher increase in female ridership than we did, but yeah, when I looked at their results and everything like that, nothing came out that was overly shocking. We showed more use on adjacent roads than they did at certain times, but like I said, that's on Saturday morning. That road is used more by cyclists than the path to school. Because when you look at the data, when we were showing when you would use a road to go to school, we had higher use on the path. So we just showed a much wider breadth of data than those groups do, because again, we have most people are only going to keep apps on their phones for maybe 3 months. If it's not engaging, interesting, and continually being updated and really pushed on them. And that's why Strava can succeed where some of these other apps can't. I mean, to use a civic-based app is it takes a certain unique individual to use it once, and it takes a really special individual to really keep utilizing that for just the promotion of good for my city. Whereas Strava can now begin to push that goodness to the city by creating this really engaging application with your friends, giving you kudos and rooting you on, and just kind of giving you great summary statistics. Because like I said, we have 110 people right now, and 15 of them are just marketing, and then 60 of them are app developers. So you have that kind of push just developing an app that it's going to be good. Yes, sir.
Excellent. I was gonna. Oh,
hold on a second.
We've got no other questions on our side here. I was going to propose that we just kind of go right into the next part.
Yeah, that sounds great, Joe. We have one question here, though.
Oh, okay. Go ahead.
This software, is
all web-based, or do an individual have to download ArcMap or something like that? How does that work? And then when will this be available for us to use?
So I believe it was last Wednesday we delivered the first round of 2012 data. 2014 was picked up this morning, and the 2013, 2015 should be done by Friday. So by the end of the week, Florida should have pretty much 3.5 years worth of cycling pedestrian data. Yes. The next question: is this ESRI based right now? Yes. It is very much GIS heavy function. You need to have a spatial database to use it.
Brian,
yeah.
Do you mind rephrasing the question so those folks that are on the line could actually hear the question?
Sure.
Okay,
the question
thank you.
was, how do you use this data, and when is it going to be available? You know, does it require ESRI? Does it require a spatial database? Does it require you know, QGIS, something like that, to view it? Sean and I were talking at lunch today about coming up with ways to view this data on a more like just slightly user-friendly way, because it can be converted to a KML, right? And then you can display it in Google Earth, and that's, you know, something that most people can get by with. I have a slide at the end here that will show you that shows Metro use. That shows some of the new tools we're developing that are as a GUI, because what we're finding is a lot of people that are reaching out to us for data aren't necessarily GIS analysts, right? It's actually it's planners, you know, people who need the data to help drive their day-to-day decisions, and that profession doesn't necessarily mean that you have a degree in GIS science, right? Or like, you know, utilizing spatial data, software. So while there's always going to be that need to have that big spatial team to do deep analysis, like a low stress network analysis, something like that, that doesn't mean that there shouldn't be such a barrier to even just being able to see the most basic things from this data. And so we're trying to create that process right now as well. So I would say by early 2016, we'll have something in place that will come with the products that will allow you to have a static HTML view to show to see what's happening with that data, with the idea that, and that's kind of what some of these questions I want to ask your group is, what is that question? What is that burning question, that first thing you want to know if you get a data set like this? Like, you know, it's going to be different for a lot of different groups based upon what your current project needs are, but there's got to be something that's going to resonate with 80% of us. It's going to say, that's what we really need. That's going to help me and my job. That's going to make my job better. And make this data more useful for me, and that's really what we want. If the data is not being used, it's just as good as being in the S3 warehouse. So. Joe, is there anything else?
Not from my side. I know we've got quite a few folks that are still on the attendees on the web. Got 167 folks that are still out there. We'll do our best to kind of capture some of your questions. I know Sean's helping with answering a few, but we'll do our best to answer those questions to the best of our ability. Yeah, awesome. I would propose now we just kind of go right into session 3.
Yeah, that sounds great. We have one more question in here.
Yeah.
Okay.
I know you mentioned working with the raw data. What was the program that you mentioned, the free program that you were using?
So the database is called PostGIS, right? And I recommended the 9.1 through 9.3 versions, and it's really easy install right now on Windows. I run Windows and Linux, and they both work really, really well. And then the spatially enabled modules for that is called PostGIS, right? So you kind of like the Postgres is the database holder, and the PostGIS is kind of all these functions and modules and extra pieces. Not GRASS. You will have to download GRASS with it, yeah. Yeah, it pulls off GRASS modules and things like that.
And then actually I had a follow-up.
Yeah.
Not follow-up, but a question. Do you guys collect any kind of crash data, or, you know, I know you mentioned notes where users can add comments, I'm assuming.
Right.
Is there anything where they mention potholes or something along, you know, lines that, or the infrastructure needs of riders or pedestrians?
So the ways for cyclists? Yeah. Yes. Right now, no, but it's definitely like one of the most exciting things we're going to be able to do, for sure. I mean, How great would it be able to be just to be able to have, I mean, not run that through spell check. Would be able to have a real-time feed of vetted issues within a system, right? Because one of the biggest problems with crowdsourced social reporting apps so far has been like one person, tired of people speeding in front of their house, he creates 50 accounts, you know, nobody knows is one person being like, someone's speeding, they're doing the 110, and really it's the same guy who reported it 50 times, right? And there's no way to vet that person out. Where with Strava, we have people on there for 6 years now. They do put in like 200 miles a week on this road, and if they report glass on the road, the odds of there being glass on that road are pretty likely. It's not going to waste, you know, he's not going to waste valuable DOT resource time to go send someone to get glass out of there, right? So I think that's something that Strava is definitely in a good position to do, and I think that will piggyback off of this thing I can show you guys at the end.